Okay, welcome. Can you guys hear me? Thumbs up, thumbs up, thumbs up. Okay, good. Good morning. Welcome to the Securing Block Storage session here at Inforce. This is session GRC207, in case you're wondering. My name is Ashish Palekar. I am with the EBS product management team. And so part of my responsibilities is working with customers such as yourselves, understanding what your needs are, and then building the products that you guys need. And so I'm extremely excited to talk and cover what we've done in the security and encryption space in block storage. Today what we'll walk through, and I'm actually going to do a show of hands in a minute, we'll walk through a little bit on the block storage in AWS, because oftentimes what I find is customers don't have the latest, greatest info, so hopefully a short blurb on that, and then we'll dive right into encryption, what we are doing with local instance storage, what we're doing with EBS, what we're doing with snapshots, and from there on, we will talk about the new features that we've just launched, so that you have a better sense of what they can do for you. Before I move on, just by show of hands, how many of you are EBS customers today? Show of hands? Lots of you. How many would say you know EBS extremely well? Few. Okay. So there's a mix in the audience. So I'm going to spend some time covering the basics of block storage, so that we can dive into the product features. So when we think of block storage in the AWS context, we really think about it in 4 vectors. One is the EC2 instance store, also called local instance storage, right? There are SSD variants for that. There are HDD variants for that. The second is on the EBS SSD-backed volumes. So that's GP2 and IO1. We'll cover that in a minute. Then you have the HDD-backed volumes, which are ST1, SC1. I get questions about what those are. We'll talk about that. And last but not the least, snapshots. And we'll cover what those are and what we can do for you there as well. So when you think of instance storage, this is either SSD or HDD. It is local to an instance, and the life cycle of the storage is coincident with that of the instance. Meaning, if you stop, start, or terminate that instance, your storage goes away. So we call it non-persistent data store. This data is not replicated by default, and you don't get snapshot support, right? So in other words, it is truly storage that is local to an instance. For our discussion today, as I'll cover later on, we'll focus on NVMe storage and NVMe instance storage and what we are doing there. So then EBS is block storage as a service. The difference, as an example, with instance storage is this is storage across a network. So it's service that is accessed across the network. You can attach and detach and create and delete volumes all through an API. The important thing to note is EBS is not a hard disk drive, right? It is not a single disk. And in fact, one of the ways that EBS provides the availability, durability characteristics is by providing storage over a large number of devices. And so in fact, your EBS volume is distributed over a large number of physical devices, which gives you the necessary characteristics. Another way to sort of look deeper into EBS is the volume lifecycle is different from the instance lifecycle. Right? The volume is an AZ-specific, availability zone-specific concept. You can attach an EC2 instance to it. You can select your storage and compute independently. And if your workload needs change, well, you can detach your EC2 instance, attach a new EC2 instance, and you go off to the races. Right? So in other words, you get flexibility in terms of moving from one instance type to another within the same availability zone. In general, it is not an uncommon configuration to have a single EC2 instance attached to many EBS volumes. However, a single EBS volume attaches to one and only one instance. One of our guidances is to separate boot volumes from data volumes. And some of that you'll see later on as well. It helps you from a manageability standpoint and an operations standpoint to separate those out. On EBS volume types, really think of these as two families, SSD and HDD. Within SSD, you have GP2, which is the general purpose SSD, and IO1, which is our provisioned IOPS volume type. On the HDD side, we have two similar volume types, ST1 and SC1. ST1 is our throughput optimized HDD, and SC1 is cold HDD. Across the spectrum of storage, we cover a wide gamut of use cases, all the way from relational databases, NoSQL databases, big data streaming workloads, file and media workloads, really a lot of variety of use cases that can use the right kind of storage. And that, I think, is the core value that customers see across local instance storage and EBS. So, GP2, this is general purpose SSD. Again, my general guidance to customers is if you don't know anything about your workload, then probably the right place to start is GP2. It's great for boot volumes, great for low latency applications, bursty databases. You get up to 16,000 IOPS, growing at 3:1 IOPS to GB, and up to 250 megabytes per second in terms of throughput, right? So it really covers a wide space in terms of the aggregate use cases. When you now look at provisioned IOPS is really designed for critical applications that need consistency with respect to IOPS, need sustained IOPS. And so its IOPS profile, the IO operations per second profile, tends to be much higher. The maximum IOPS that you can get on an IO1 volume is 64,000, right? And your throughput is up to 1,000 megabytes per second. You can provision storage at 50:1 IOPS to GB as compared to 3:1 that was on GP2. Switching gears to the HDD types, ST1 is our throughput optimized. So you get up to 500 megabytes per second in terms of your baseline, and a burst as well of 500 megabytes per second, with your capacity ranging between 500 GB as the minimum entry point, all the way up to 16 terabytes. It's really designed for workloads that are large block, high throughput, sequential workloads. That's where HDD workloads shine, and that's where ST1 is focused. If you look at SC1 gets a baseline of up to 192 megabytes per second, but with a burst going all the way up to 250 megabytes per second. Again, similar size dimensions, going from 500 GB minimum all the way up to 16 terabytes. Really, again, designed for sequential throughput workloads, obviously not at the same level of throughput as ST1, but if you have logging and backup workloads that need this kind of throughput, then SC1 is a really ideal workload for those use cases. And then snapshots. Really the way to think about snapshots is a copy of Amazon EBS volumes stored on S3. In that sense, snapshots are different than EBS, and we'll touch on this a little later in the presentation as well. Snapshots are regional, right? While volumes and instances and instance storage are zonal, snapshots are regional. The first snapshot is a full copy of the volume. Subsequent snapshots are incremental, right? You can create a snapshot from a volume. You can share and copy a snapshot. That's different, right? And then you can create volumes from snapshots as well. And so these characteristics make snapshot interesting from a security standpoint, and we'll cover some of that later on in the presentation. So with that really brief overview, let's dive right into encrypting block storage and what's entailed and what's involved there. So to kick things off, let's look at local instance storage, right? In this case, NVMe local instance storage Who here uses any of these instance types? C5D, I3N, show of hands? Some of you. So with these instance storages, when you provision the instance, say a C5D or an I3 or an I3EN, you get a local instance store. These drives are always encrypted. They cannot be disabled. You cannot change the encryption key. So by definition, you get encryption on those volumes. In case you're curious, it uses XTS AES 256 as the block cipher. It is implemented on our Nitro module on the instance, and the keys are unique to each NVMe instance store device, right? So it really tries to separate the security from that standpoint. And finally, when you instance stop or terminate, that's when the keys get destroyed. So the life cycle from a security standpoint, from an encryption standpoint, is completely local to that instance, right? So it starts with the instance, the keys are local to the instance, it's always encrypted, and then when you stop or terminate, those keys get destroyed. EBS is a little bit different. EBS integrates with Amazon Key Management Service, something I'm sure you've been hearing a lot about at this conference. So with KMS, we use AES 256 encryption, and we use customer master keys. So if you hear me using the word CMKs, that's what I'm referring to. So what does encrypting an EBS volume imply? It implies that the data at rest inside the volume is encrypted. It implies data moving between the instance and the volume is also encrypted. It implies snapshots created from that volume are also encrypted. And it implies volumes created from those snapshots are also encrypted, right? So in other words, encrypting a volume ensures that all those specific pieces of storage going from instance to EBS, from EBS to snapshots, and any subsequent volumes created from that snapshot are all in an encrypted state. So how do you enable encryption for EBS? Really, if you go to the Create Volume console screen, within the Create Volume console screen, there's a button that sort of says encryption, and I'll show you that. You get to select the master key. This is where we talked about the CMK piece. To create the master key, you go to the KMS console. In that, you create a KMS master key for your EBS account, right? And I'll show you an example of how that gets done. There, you get to define your key rotation policy. You should enable CloudTrail auditing, how the key gets used, what the logging around that key is. You can control who can use the key, right? And last but not the least, you can control who can administer the key, who should delete the key, who should change the key. All of that gets managed within the KMS console. And after you have worked through and defined sort of a master key, you get to select that, right? And really, in the Create Volume console, you get to then have volumes that from that point on are encrypted for that particular volume. If you're a customer that uses run instances, you can do it from the run instances console. So right-click on the volume, and you'll get these options to go select on the encrypted bit which master key to use in order to encrypt your data. If you're a CLI kind of guy or gal, then here's the run instances CLI. You'll provide a mapping.json and then specify the KMS key ID to help you encrypt your volume. So I'll dive a little bit deeper into how encryption works for EBS. We use what's known as envelope encryption, right? And what this means is there is a hierarchy of encryption that gets built in. Specifically, what you have is a master key. And that master key is created within our key management service, so KMS. And in fact, that master key never really leaves KMS. But within that master key, you have a set of data keys. And those data keys can be used for individual volumes. So you'd say, why do it this way? By enveloping your data keys within a single master key, you reduce the blast radius of a single key getting exposed, right? And so from that perspective, each of your data key corresponds to an individual volume, and the data key itself is stored in the volume metadata. So when you now attach an instance, then the instance connects to KMS, uses the master key to decrypt the individual keys. That key is stored in the memory of the instance. So the decrypted key is in the memory of the instance. Again, never persisted because we want to make sure we protect the blast radius. And that's how encryption works. So in other words, you don't have a point in time where the master key is taken out of KMS. So why do we do it this way? We do it this way because, one, I talked about it, it limits your exposure risk. Second, it enables high performance because now the decrypted key is local to the instance and you get the full performance of the EBS volume. And last but not the least, it simplifies key management because you can change the master key, you can rotate the master key and work with the master key instead of having to manage keys for each individual volume, right? So again, thought through, understand, and that's basically how your encryption within the EBS context works. So a very common question that customers ask me when I talk to them about encryption is, hey, does using encryption mean that it will reduce my EBS optimized performance? And the answer to that is quite simple. If you're using the 4 and 5 family of instances, which I bet most of you are, then EBS optimized performance is the same with or without encryption. In other words, the rated performance of an instance doesn't change, whether you're using encryption or whether you aren't using encryption, right? So you get the same performance. And again, so there is no encryption penalty that some customers expect there to be. And so again, from a performance standpoint, you have exactly the same performance whether you are encrypting an EBS volume or not. So switching gears from volume encryption, so we covered instance storage encryption, we covered EBS volume encryption. Let's switch gears to snapshot encryption. So snapshots, we talked about this a little earlier. Snapshots of encrypted volumes are automatically encrypted. Volumes created from those snapshots are encrypted too. So if you have encrypted snapshots and you're creating volumes, those volumes are automatically encrypted. You can encrypt an unencrypted snapshot when you copy a snapshot. And then you can re-encrypt a snapshot. If you're changing keys, you can re-encrypt a snapshot with a different key when you copy a snapshot. And actually, some of the things that I'll talk about a little later are going to focus on those last two parts because we see this as a common pattern that customers do. And so we've built some things to help you solve that problem. So I touched on this earlier, but snapshots are different than volumes. In what ways? First, snapshots can be shared across accounts. Snapshots can be copied across accounts. Snapshots can be copied within accounts. Snapshots can be copied across regions. And snapshots can be used to create AMIs, right? And therefore, this gamut of use cases that snapshots gets used for is just different from a volume. And so you have to think about security when you're sharing snapshots. You have to think about security when you're copying snapshots. And you have to think about security in the context of snapshots as well as AMIs, right? And that's exactly what we're going to do now. So let's start with sharing. How do you go about sharing a snapshot? Go to the EC2 console, right-click on a snapshot, and you get the key, the menu item there that says Modify Permissions. Again, if you're a fan of the CLI, then you can use the Describe Snapshot attribute and Modify Snapshot attribute, and that should give you a JSON. So this one doesn't have any permissions as an example, but that's what gives you the ability to go change. So if you now click on that Modify Permissions menu, up pops this. your snapshot can be public, your snapshot can be private, and private shared with no accounts, or private shared with a specific account number, right? So you get those three options. The default is private, then you get to make it public, or you get to share that snapshot privately with certain accounts. So here's one of the conversations. Public sharing of snapshots is a reasonable use case for AMIs, right? As an example, if you have a marketplace AMI, you want customers to use it. You want other partners to use it. And that's a reasonable use case for public sharing. For non-AMI snapshots, for non-AMI snapshots, super important that you share it with specific accounts. In other words, you don't want non-AMI snapshots that have important data just open to the public, right? The other thing for you to realize is to launch a volume, especially if you're sharing across accounts, you need a copy in region. So in other words, you can't share a snapshot and then automatically launch a volume in a different region. So one of the questions we get is, how do I check if my snapshot is public? So in the permissions tab, so actually if you go in the EC2 console, right below in the snapshot itself, if you go to the permissions tab, you will get a descriptor that says your snapshot is currently public. Again, if you want to look at it through the CLI and you do a describe snapshot attribute, you will get a group all permission there that will indicate that your snapshot is public. Again, it's reasonable if it's an AMI related use case. In general, for snapshots, make sure you're sharing it with specific accounts. Okay, so that's on sharing. Let's switch focus to copying. So snapshots can be copied across regions, right? And one of the reasons to do it is you want to create a new EBS volume in a different region. So it's not uncommon to have customers copy snapshots from one region to another. Things to remember while copying. Well, S3 encryption protects snapshots in transit during a copy operation. Independent of sort of whether the snapshot is encrypted or not, S3 encryption will protect snapshots in transit during the copy operation. Unencrypted snapshots can be encrypted during the copy. Encrypted snapshots can be re-encrypted during the copy, right? The other thing, which was a feature we launched last year, while your first copy is a full copy, your snapshots are incremental after the first copy. For achieving incremental snapshots for encrypted snapshots, you need the same CMK applied to both ends of the source, both ends of the copies, right? Because if the CMK is not incremental, then you do end up getting full copies. Okay. How do you encrypt or re-encrypt a snapshot? So you select the copy button, same menu item as before, and then you get an option that says, go ahead and encrypt my snapshot, right? You get to select the key, you get to select the account, you get to select which key to use for encrypting that snapshot. You also get to select the region. You can do it within the same region as well. And here's what the CLI for that looks like. You can copy snapshot, you have to specify the KMS key ID, you have to specify that you want it encrypted, and then you will get a new snapshot that is encrypted with the KMS key ID that you had provided. In fact, we see some interesting use cases that customers have built around this. So one of the customers, what they've built is this mechanism to copy snapshots from one region to another. So they produce snapshots in one region, copy it from one region into another, into a different account. And in that different account, then they lock down resource level permissions so that extremely limited number of people have access to that snapshot. Why do they do this? They do this really for two use cases. By going multi-region, they protect against regional failures. That is one of their concerns that they want to protect against. And by doing the permissions lockdown, what that allows them to do is protect against malicious or unintentional deletes, right? So in other words, they always will have a copy of their data in a second region that is protected from being deleted. So this entire space of encryption has recently, we've done some major changes, and we've launched 3 new features that should hopefully make your lives as customers simpler. The first is launching encrypted volumes from unencrypted snapshots or AMIs. The second is sharing encrypted snapshots with custom CMKs across accounts. And the last is encryption by default within an account in a region with a single setting. And I'll walk through each of these features and sort of how they work for you. So let's start with encrypted volumes from unencrypted snapshots or AMIs. How many customers, and with a show of hands, have recently gone through somebody coming down and saying, man, we better make sure that all our data is encrypted? Show of hands? Few of you? How many of you have snapshots or AMIs that are unencrypted that you need to use today? Right? So there you have a contradiction, which is how do you go from a set of unencrypted snapshots and AMIs into a set of encrypted volumes? And the way that customers do this today is, and I'll walk you through, and you guys can tell me if you do something different. I'd love to know. Take an unencrypted snapshot or AMI. You then copy and encrypt that snapshot, which I showed you earlier. And once you copy and encrypt that snapshot, you then end up creating a volume, right? An interesting variant of this use case, by the way, is if you want to change your encryption. So if you have one set of encryption keys and want to change to another encryption keys, you'd follow the same process, right? Starting from an AMI, copy the snapshot over, and then launch a volume from that. So with this launch, which we launched in May, what we did is we gave customers the ability to take an unencrypted snapshot or AMI, in a single step, launch an encrypted volume from that. So no more copying of snapshots. If you don't need to, you can directly just launch the encrypted EBS volume from an unencrypted snapshot or AMI. So to my previous question, where you guys raised your hands and said, well, I have unencrypted AMIs and snapshots that I need to launch volumes from, this should work, right? You can do exactly the same steps if you want to go and change the keys from one snapshot to another, one snapshot to a volume. So how do you do this? Go to the create volume console, right? You'll say create volume from a snapshot. And in the create volume snapshot, you get the option now of encrypting this volume. And by encrypting this volume, you get to, again, select the master key. It doesn't care that the snapshot underneath is unencrypted. You get to do the exact same thing on the create volume interface, right? So the create volume interface will accept the -- encrypted. You can specify a different key. In this example, I didn't, but you can specify a different key as well. The benefits are pretty straightforward. It's simple, right? You get a single step to launch encrypted volumes. It's compatible. You don't have to go back and re-encrypt all those AMIs and snapshots if you don't want to. It saves you time. You no longer have to create a copy and actually wait for it to complete copying before launching your volume. And last but not the least, it's less cost, because you no longer have to have these copies of encrypted snapshots just because you want to go launch volumes from them. So again, quite exciting to see this feature in customer hands, and we're definitely looking forward to hearing feedback from you on whether this meets your needs. Second piece that we'd launched, sharing of encrypted snapshots and AMIs across accounts. How many of you have multiple accounts within your company, multiple AWS accounts? Almost all of you, right? And do those accounts need to share snapshots? How many of you need to share snapshots across those accounts, right? How do you solve the problem of encryption today? This is how you do it. So a good example of this use case, by the way, is having an AMI bakery, right? Customers who have AMI bakeries that say their IT team is churning out that need to be consumed by a different account or by a different team or a different workload. This is one of the things that they manage through. So what you start with today is you have a snapshot or an AMI that is encrypted with a custom CMK. In that case, you have to copy that snapshot across accounts, right? Using the same techniques I showed you before. And once you've now shared it across accounts, you can then launch the volume from that account, right? By the way, encrypted snapshots up until this release could only be shared, could only be copied across accounts. In other words, you couldn't share encrypted snapshots across accounts. So what's changed? Now, with the change that we've made, what you can do is take an encrypted snapshot or AMI, which has been encrypted with a custom CMK. You can share that snapshot across accounts. So your second account needs permissions to your key, and you can provide a second key for the re-encryption in the second account. And with that, you can launch volumes that are encrypted by sharing snapshots or AMIs that are encrypted with custom CMKs across accounts. My one caveat is that if you have snapshots that are encrypted with default CMKs, those cannot be shared, right? And it's one of the reasons that I definitely, for customers who are interested in this use case, I ask them typically to build snapshots with custom CMKs, because default CMKs today cannot be shared across accounts. That's why this use case is addressed for snapshots that are encrypted with custom CMKs. So how do you do this? So it starts with actually giving your CMK permissions to that second account. So you go into the key management KMS console. In that KMS console, you add in permissions for the new account. And that permission is to describe key, re-encrypt key, create a grant, and to decrypt, right? It doesn't mean that they have access to the key within their account specifically. What it does mean is that they have access to be able to decrypt the data from the snapshot itself. And so from that point on, you can use run instances with your mapping.json. And in this case, the mapping.json now specifies the new key you want in your target account, right? So you went from a snapshot or an AMI that is encrypted with a custom CMK into a volume that you've now encrypted with your own key. Again, similar to the prior use case, it's simple. It's a single step to get to launch encrypted volumes from snapshots. Once you set up the key sharing, you can save time. And again, less cost because you're not maintaining additional copies. Putting these two features together is actually super interesting. Because let's say you have an unencrypted snapshot or AMI. Previously, what you would do is copy that snapshot across accounts, re-encrypt it, and then launch a volume that is encrypted. With this change, you can just share the snapshot across the account and launch a volume. So in other words, you can go from an unencrypted snapshot or AMI into an encrypted volume across account, all within one step. Again, my same caveat as before, this works for unencrypted snapshots and for snapshots that are encrypted with custom CMKs. Today, it doesn't work for snapshots that are encrypted with default CMKs. Okay? So now bundling all this together, because some customers came to us and said, well, we want to make sure that we don't have EBS volumes or snapshots that are created in our account that are unencrypted. And so what they came to us and said is, would you give us the ability to ensure that the EBS volumes are fully encrypted? Here's what they were doing previously. You had an account, and in that account, volumes could be created that were encrypted or unencrypted. You had to set identity and access management policies in order to ensure that the volumes that you have were not, if they were unencrypted, you could go ahead and kill those volumes, right? And so that you could do with setting identity and access management policies. Another thing that administrators used to do was actually take snapshots of those volumes, copy and re-encrypt those volumes, attach them to the same instance, and then delete the old volume. So in other words, you had to have workflow changes in order to manage sort of how customers were keeping track of encryption. And this was complicated. So what did we do? Now, with a single account level regional setting, you can go in and ensure that all subsequent EBS volumes and snapshots created are fully encrypted, right? This is without change to workflows. It works for newly launched volumes as well as snapshots that are encrypted in that account. How do you do this, right? You go into EC2 settings, and within the EC2 settings, there's now an option, in case you guys haven't checked it out, it's an option that says, always encrypt my EBS volumes. You select your key. I strongly recommend you select custom CMKs for this feature, and that's it, right? From that point on, your volumes and your snapshots in that account become encrypted. Your benefits are, it's simple. That gives you a way to ensure compliance without changing your workflows. So a lot of customers would come ask about, well, how do I manage this in a compliance environment? This helps you do it. It's compatible. It makes it easy to introduce encryption even if you have unencrypted snapshots and AMIs, right? And it's a default it's an opt-in. In other words, you get to choose today which accounts you want encryption for, and which accounts you don't need these encryption capabilities for. Okay? So in closing, if you remember nothing else about this session, I have two key takeaways I want you to remember. One is monitor your access, right? Keep tabs on which snapshots you're sharing, why you're sharing those snapshots. Second, account level encryption. Encryption is a checkbox. I'm not even saying metaphorically, it literally is a checkbox. Go ahead and use it, right? We'd love to see more customers adopt this feature. Please take the time to complete your survey, and thank you for your time. I'll hang around. I'm happy to geek out. If you have more questions, happy to take those. Just please stop by. Thank you so much for your time.